All right, welcome back. So this is a second video. I had to create a new video after the program crashed and had to restart Windows. So where we left off was I showed you to start the SDK and to create that Hello World program. And we did that. We had X parameters we added and this XGPIO underscore L. This is for the low level functions. Now in the X parameters, our buttons and the LEDs are assigned to this address here, xparam GPIO 0 base address. You could either use this name, or you could just copy in the hexadecimal address. So I copied it here so we know what we're using. So I'm going to have two variables, print x p buttons. This is for our push buttons. When you start off, your program will have initialize, platform, a print hello world, a cleanup, and a return 0. So I added this code here. So I have some stuff coming out just so that the serial communication won't show a lot of information. Okay, so I'm going to have a loop, a for loop, that's going to print 9 items, and then we enter an infinite while loop that's just going to read the push buttons and then write them out to the LEDs. So let me show you what it should look like. So we have 4 push buttons, and then we have 4 LEDs here. So I push one button, we see an LED turn on for each button. If we do a sequence, we see 2 of them, 3 of them. I can push all 4. We see all 4 lights light up. All right, so that is what our item will be doing. Let me get back to the code. Okay, so how does this work? Well, okay, so first item we're going to be looking at is, okay, we have push buttons is equal to, and here is a read function that we're using. It's XGPIO read register. It's going to take in 2 parameters. It takes in the address, followed by a comma, and then this number here is an offset. The offset is how many new addresses over from the base item. Then we have XGPIO write register address. It's going to have an offset and then the value that we want to write. So let's go back to our block diagram. And in our block diagram, we look at our GPIO. We see that LEDs does not have a number and push buttons has a number. So the LEDs do not have a number, so that has no offsets. The number is which register it will be. So no number is register 0. The number 2 is register 2. Every register is 4 bytes long. So it will have an 8 because 0 is register 0 is offset 0. Register 1 is offset 4. Register 2 is offset 8. So we're going to read register 3. So we're going to read register 2. So we're going to read an offset of 8. Whatever value we get, we're assigning to this integer push buttons. Once we read it, then we're going to write it to the first register, which has no offset. Then we have 2 different prints. You can see we have a print. This is the basic one you can do. Is not able to print out formatting like printf. And then we have this XIL printf, and that is able to. XIL printf will take a lot more memory. So you need to have that, you set up your system with at least more than 8 kilobytes. If you do 8 kilobytes, you will not have enough memory to put this function in. So I would try to minimize the usage of this unless you really need to. You should really use the serial port just to give some type of debug information. So another item is, if you look at the top, when you create this hello road, you'll see that you have two different UARTs up here. We're going to be using the 9600 speed. So when you're going to want to add in under SDK terminal, if you add the plus sign, you can create the connection to the serial port, select which COM port you're on, and make sure the baud rate is set to that 96. So I already have it set up, but that's what you'll need to do. All right, so let's put in these printfs so you can see what they do. So I uncomment them. When you hit save, it'll automatically build for you. You can hit build if you want. If you want to build, right click, build project. Okay, so let me stop the terminal. I think this is what caused my program to crash last time. When you first set up the SDK, what you should do is program the FPGA, go down to Xilinx, program the FPGA, and then you'll hit program. I think I had a crash where the terminal locked up, and I think it might be because the USB cable is both the programmer and the serial port communications, and maybe it was trying to read in serial port and the buffer got full. So I stopped it just to be safe. So let's go ahead and reconnect onto it. Maybe that won't stop the system from crashing. Okay, so this Xilinx program FPGA, you just have to do once. When you start the program up, if you were to close the program and restart it, then you have to do it again. Then you will hit right-click on your tests. So this is going to run pretty fast. So let's just do the first printf. So you can see that it does the 10 for the loop. All right, so we'll hit run as launch on hardware. Do you want to rerun, relaunch? Yes. Okay, so we can see it did the loop 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we do the P buttons, we can put that back in. Save it. Run as launch. So you'll see keep putting 0 because it's in that while loop, and then as I press the switches, you see that they light up. The values will change. All right, so that's our simple program on how to do a system on chip. Next time we'll look at adding in a little bit more complexity. So I'll see you in the next video.